Welcome to Mrs. Mulvey's Math Movies. In this episode, we're going to talk about simplifying complex fractions. First of all, it's helpful to understand what complex fractions are. Complex fractions are simply a fraction within a fraction. For example, if I have a over b all over ax over b squared. Now I've got a complex fraction. I have a fraction here and here within the larger fraction. There are actually several methods for simplifying complex fractions. I'm going to show you one method that always works. There may be a more efficient way for some of the examples that I'm going to show you, but I'm going to show you one way that always works. And so what you're going to do in order to simplify the complex fractions is you're going to multiply the numerator and denominator by the common denominator. In this case, that common denominator would be a b squared. Basically, we're looking for the least common multiple of each denominator. So if I multiply this by a b squared, and I can even write it as b squared over 1 if I want, that will cancel, not really cancel, we'll factor out the b squared here and here. But I can't just go and multiply fractions by anything. I have to maintain the value of what I started with. So if I also multiply by the b squared over 1 up here, now what I'm really doing is I'm multiplying by b squared over 1 over b squared over 1, and anything b squared over 1 over itself, b squared over 1, equals 1. So really what I'm doing here is I'm just multiplying by 1, and when I multiply by 1, it does not change the value of what I started with. So that's what lets me do that, because really I'm just multiplying by 1. So what happens here is gadink, gadink, the b squareds factor out and are replaced with 1s. Over here what happens is this is a b to the first, and so the b to the first factors out and gets replaced with a 1. But here, remember when you divide variables or factor them in this case, you subtract their exponents. And so the one with the smaller exponent is gone, b to the first is gone, and then I subtract the exponents, and 2 minus this exponent of 1 gets me 1. And so I'm left with b to the first. Now I multiply. I have a times b in the numerator. I write that as ab. I could write it as ab over 1, but anything over 1 is itself, and then I'd have a complex fraction again if I put it over 1, and I don't want that. So I just leave that as ab. Down here, I'm left with ax. Then I look at this and see, hey, there's a common factor there of a over a. The a's factor out, get replaced with 1s. So I have 1 times b over 1 times x, and that's b over x. And that's my final answer. So let's look at one where there's some addition or subtraction in the numerator or denominator. So let's take a look at this one. I've got 2 over a plus 3 over a plus 2 over a. Now it would be really tempting to go in there and factor out the 2 over a's, but you cannot do that. You can only factor out factors. These are addeds. They're being added on. So you cannot just cross them off. You can only factor out things that are being multiplied. So what I need to do is I need to multiply to get rid of the denominator. If I multiply by an a, right here, that'll get rid of that a denominator. But of course, I can't just multiply by a. I've got to multiply by a over a, because then I'm multiplying by 1 and I'm not changing the value. And so what happens is I need to now distribute this. And so I have the a times the 2 over a, plus the a gets distributed here as well, a times 3. In the denominator, I also distribute. That gets me a times a. My plus comes down, and then I have the a times the 2 over a. Now, if you want, you can write this as a over 1, just to kind of help you hold the numerator and denominator. You don't have to do that, though. And so what happens here is the a's factor out here. Ka-dink, dink, they're gone, replaced with 1s. Nothing factors out here, so I just leave that alone. Nothing factors out here, I leave that alone. But here the a's factor out, ka-dink, replaced with 1s. And so now when I look at this, I have 1 times 2, it's 2. My denominator is now 1, so I'm just not going to write it. Over here I have a times 3, that's 3a. Down here I have a times a, that's a squared. And then I've got plus 2. And so my final answer, I'm just going to write this with the variable first because addition is commutative. I have 3a plus 2 in the numerator, a squared plus 2 in the denominator. Nothing there can be factored. And so I'm done. That's my final answer. So let's try one more. This time we're going to have 5 over x plus 1 over 2x in the numerator, and an x plus x over 2 in the denominator. So again, my goal is to multiply to get rid of the denominators in each of the numerator and denominator. And you can think about that least common multiple, or you can simply ask yourself, what would I need to multiply by here to get rid of both an x and a 2x? And you would need to multiply by a 2x. And of course then you need to multiply by the 2x in the denominator as well. And what happens is that 2x will take care of this denominator and this denominator, and then down here it will take care of that one as well. So when I distribute, I have 2x times 5 over x. You can write that as 2x over 1 if you want. Plus comes over, and then you have the 2x times the 1 over 2x. And again, you can write that as 2x over 1 if you want. Down here, we have the 2x times the x, plus comes across, and then I have the 2x times x over 2. And again, I'm going to put that 2x over 1 just so I can clearly see my numerator and denominator. So now I look at what factors out. I look at each section here now. And here I see the x's factor out. So, ka-dink, they're gone. Here the 2x replaced with 1, so instead of 2 times x, now it's 2 times 1. Instead of 5 over x, it's 5 over 1. Here the entire 2x factors out and gets replaced with 1s. Here nothing factors out. Here just the 2 factors out. So I'm going to factor out the 2. So instead of 2 times x, I have 1 times x. Factor out there, gets replaced with 1. And now I simplify. I'm left up here with 2 times 1 times 5, that's 10, plus 1 times 1, that's 1, my numerator. Down here I have 2 times x, that's 2x squared. And then I have x times x, that's another x squared. And so when I simplify this, I've got 11 in the numerator. 2x squared plus another one gets me 3x squared in the denominator. So that's it. Let me know if you have questions. Bye-bye.